Okay, so this is Giovanni, and I wanted to talk about a particular topic that has been on my mind in the last few days. I made a lot of posts on my X account, and first of all, I want to explain why I'm so focused on discussing this topic because it doesn't have to do anything with claiming my model, the power law model, is better than anybody else model. It's about being a scientist. I want to understand things, and I want to make sure that what we are talking about is based on solid ground. In particular, because there is a lot of stake, right? A lot of people rely on our work as Bitcoin researcher, Bitcoin scientist, Bitcoin explorers to make decisions, DCA, buying, selling, etc. So we have certain responsibilities. And to me, it's very important that nobody's perfect. We could all be wrong in making these models, but at the same time, we need to be as close as possible to at least some basis of truth. And after spending a lot of time trying to understand not just my model, but other models, I arrived to the conclusion that this very popular model that has lost some popularity since last cycle because there were some prediction that people relied on. They were not. They actually didn't happen, and then there was a lot of disappointment. Right? But now, with the new cycle, people are coming back to it, and it would be okay if it was an alternative model, right? And in a sense, it turns out the S to F is almost the opposite of what power law is, because one model is much more conservative, it is the power law. S to F is an exponential model that is supposed to grow very, very fast in time. And they have also very different philosophy, different approaches, etc. So it will be okay and it will be perfect. Like you have two alternative models. Let's see which one is correct because more data comes in and one of the model can be uh, to be incorrect. What we call in science, one of the model can be falsified, or both model can be falsified. It's perfect. But after studying it and trying to understand carefully and study this entire concept of stock to flow, my conclusion is that it's just pure nonsense. It's basically what Plan B discovered is the power law, but in a deformed fashion, and he added to it some conditions that are not supported by data. And it's not just a question of philosophy or understanding concepts, because that is also important, but comes later. Okay, we can discuss them in another video. We can think about them. We can explore them. We can reflect on them. But this is not about philosophy. Okay, so I want to show you this is what Plan B posted today, commenting on me, and his main point, and this post came mostly from me posting some kind of a proof, mathematical proof, that S2F is kind of nonsense, because it turns out that it's basically time. It's a silly type of measure that I think it makes sense to economists, that is not how a physicist will think about the same type of problem. And we are dealing all the time. Physics is a science of change. We know how to talk about change. We came up with an entire vocabulary, and we have equations. So we are trained, for years and years and years to talk about things that change. We have equations, we have models, we have tools, we have definitions. So we know what changes. And we are talking about this quantity stock to flow. It is supposed to be all about changes. Okay, flow is a rate of change, for example. Stock grows proportionally to the flow. So these are quantity that are things that we are using physics. At the same time, this silly stock to flow definition is something that a physicist will never have done, because there are other ways to talk about these concepts, and it's kind of a nonsense how it's defined. But we can still stick to the definition and then see the definition of this concept, stock to flow, what leads to, okay? And when you really understand it and you actually play with the math, you find out that it's complete nonsense, absolutely nonsense. And in fact, you can use it to model basically anything. You can show that anything that behaves in a certain way, if an underlying phenomena it's of a certain type, then you can make a stock to flow model introducing an arbitrary concept of scarcity that has absolutely nothing to do with what you're describing, like an object falling down, for example, and it still works. That shows how silly this quantity is. And in fact, not just that, okay, I give you a preview of what we are going to talk. I can also take the flow and make it grow and apply it to Bitcoin and show that actually I can predict even better than Plan B what Bitcoin is doing with some arbitrary quantity that grows during bulls. And I make a joke, I can make it proportional to FOMO, I can make it proportional to many bad calls Kramer is making, whatever. Okay. And you can see, because I timed it correctly, associated with these spikes in price, that actually I can predict the peak that Plan B cannot do in his model. I can predict the peak. I can, in fact, actually calibrate exactly how big these peaks are going to be. And I can tell you when the bear market starts it with my model. And it's all based on literal bullshit. Okay, sorry for the bad word, but it's literal bullshit, because it's a made up model. It's not based on any concept, So all this talk from Plan B about understanding scarcity, swab, eventually uh, Zabo, and so on, it's useless. It's like mirrors, smoke and mirrors, because it doesn't address the mathematical problem that I mentioned. It doesn't talk about it. Tell me, Plan B, please tell me why do you think my arguments that I'm going to show through, basically applying this same procedure uh, to different approaches, different situations, and actually changing things like the float, making positive versus negative, it's wrong. And and Akam, this modification I'm making can predict the price of Bitcoin better than your stock to flow model, based on scarcity. And we can use a stock to flow to model perfectly the fall of a falling object, the motion of a falling object. It makes no sense. So let me move a little bit forward, and this is what he was referring about. Swabo, I can never pronounce his name correctly. Sabo, he's like one of the founders of this entire uh, movement related to cryptography, and that he was one of the pioneers. Some people even think that maybe is Satoshi himself. An amazing guy, genius, etc. And one day we can go back, to some of the things that these founders said, or I think they're thinking behind this idea of scarcity, and I will show you the scarcity has nothing to do with Bitcoin, really. It's the wrong concept. Bitcoin has many properties, and one of the property is that it's a ledger, and it's as a fixed, total cap of coins, and these are wonderful property. I'm not against them. I'm not arguing against them, but they have different functions. And notice how he mentioned function here, simple functions here. It's all about function and what these things do, what the cap is supposed to do. Okay, we can discuss it another time, because it's not really the focus of this video. I'm trying to talk about more of the math of a stock to flow model, and I want to show that has nothing to do. The model itself has nothing to do with scarcity. It's an illusion that has to do with scarcity. There is no scarcity in that model, or at least the scarcity introduced has nothing to do with the price. And I will show you in a moment. But these ideas are very interesting, very important, and we can discuss it another time. And I can tell you what I think and why we can come up with other ways of talking about Bitcoin that still, communicate the wonderful quality of Bitcoin, the fact that it is so valuable and precious, but without invoking this concept of scarcity that is, one, wrong, and two, also a very bad concept that can turn off people, I think. But let's not go more uh, in depth about this right now. We can revisit another time. So the other, this is the famous Plan B article that you know for some time was what everybody was talking about, right? Starting from this date of 2019. Notice, by the way, that my discovery of a power law. So I started to talk about the power laws in Bitcoin since 2014, but the main discovery about Bitcoin having this power law in time predates this article about at least 1 year. Uh, and so, this article comes later. Um, and it's all about, he's trying to use scarcity. And I think this is part of why it was so popular, because the scarcity idea was pushed by so many Bitcoiners. It's one of the things that I don't agree. I like a lot the Bitcoin standard. There are a lot of beautiful ideas and history, etc. But the emphasis on scarcity is one of the things where so many people fail in describing what Bitcoin is about, And it's okay, because we are all exploring, we are trying to understand. It's a unique phenomena. Everybody comes in with their, the author of Bitcoin Standard is an economist. He comes with his economy ideas that fortunately there are no the conventional one. They are from this Austrian school that is so much better than anything else there, but it's still influenced by old ideas. They apply to other type of currencies, other type of monetary systems that really Bitcoin is overcoming them. Yeah, Bitcoin doesn't need scarcity. Well, this is what I'm trying to say. It's not because we buy Bitcoin because it's scarce, so there is value because of scarcity. It's coming from something else. But Balambi, he was exploring, and I think its main contribution was something that should have been obvious to all of us. But a lot of things with Bitcoin seems obvious until you discover them, and then you think, why I didn't think about that, And so it's great. His main emphasis, his main contribution was in recognizing that Bitcoin has these bubbles, right? That they say they are evidence, they are there. But for example, myself, I always was worried about these bubbles because I came in a time right early on, since 2012, when people were still talking about tulips, 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 tulips. I knew that Bitcoin had nothing to do with tulips, but it kind of scared me a little bit, not because I believe that Bitcoin was tulip, but because I thought this could turn off people from Bitcoin. So I always hated this idea that the bubbles were, even the name bubble I didn't like. But now it's okay name, because this is what is used to describe other times when people get really excited about some kind of asset, and then there is this frenzy, they buy, when the price crashes. They are bubbles, but they are temporary bubbles, right? They are part of history of Bitcoin. And so Plan B wanted to introduce them in how we discuss about Bitcoin, and it assign some very great importance to them, like really the driver of the price. The general behavior of Bitcoin can be described by this bubble, and this bubble are caused by what? But his idea was they are caused by an increase in scarcity. Okay, like Bitcoin is already scarce, but it becomes even more scarce every time there is an halving. And it's an hypothesis, an okay idea. You can explore it. There is nothing wrong. But even if we accept this idea of scarcity, and like I said, I don't agree. I want to show that actually this model doesn't do what it's supposed to do. That is the worst thing, because one of the criticisms that you can do about the model is not just that it doesn't explain something correctly, but it's inconsistent within itself. That is really the fatal blow that you can give to any understanding of anything. If you are not even consistent with your own approach, and you say you're going to do something, like in this case, Plan B wants to explain that scarcity actually is a cause for the price change, then you fail. In model fail, and it's not a question, oh, you fail and I'm making fun of you. It's a question of, okay, we should retire this thing because it's not just wrong, it's useless and nonsense. And so if people use them, doesn't matter how emotionally attached you are to it, then it's you can use anything. There are people that use the moon phases, or the distance from Mars or the Earth. You can use whatever you want, but going around and repeating this is a good model, let's see what it does so we can do some decision. It's irresponsible. It's not good, and people should not follow that particular model. Plan B has many other good devices. He has other ways of looking at Bitcoin. So it's still a great contribution to the community. But S2F is, at this point, I think, is actually reckless. It's not just a question of not being good. It's useless. It's not good. Okay, and so let me do the next step, that is basically trying to, because many people are kind of a little confused about what these things are, what stock is, what is flow, etc. But a relatively simple concept. What is confusing, that was confusing even to me, is this ratio between stock and flow. Because when we say stock to flow, this is what we mean, that there is a ratio between stock and flow. And what is used for, what does it mean, how it can be interpreted, we are going there. But basically, it's something very simple, right? Imagine there is some kind of quantity, and most of the time is used in the economic context, and so we can describe it in that way. But also, really, if you want like a little physical model, it could represent water in a container, and you have a faucet that brings in water, for example, and you know how much water is coming in. Then you have some kind of hole, like maybe some kind of a sink or whatever, and the water comes out. Then you want to know, given this inflow and outflow, and you sum it together, that is what the total flow is. So you sum both the positive contribution, that is this water coming in, and the negative contribution, the flow that comes out. And so you have how much water, how much capital, how much gold, how much grain, anything that, if you want to go from a physical example to a more financial one, we are talking about like something like grain, for example, right? We have grains coming in, it's produced by farmers, and then we are selling or distributing the grain to the people. There are little mouse eating the grain, etc. So there is a loss, and you sum these two things together, the positive and negative, and that is the total flow. When you compare it with how much stock we have, how much of this thing that we are interested, it's accumulated so far. And you can see all these, of course, is dynamic. That means it happens in time, it changes, and so on. Okay, so it's a relatively simple concept, and we could be interested in this because maybe we want to plan. If should we increase production, should we decrease it? And so it's interesting from like an economical point of view, because it gives us an idea of what is available to us, and right, if it is food, or maybe if if you don't want to depreciate too much, like the production of gold, so maybe or oil, for example, right, when we cut the production of oil, because otherwise the prices go down too much or whatever. So it's an interesting quantity. Okay, so and then so when we are, and by the way, I'm using Wikipedia, and I'm already waiting for somebody to say, look, he's using Wikipedia. Can you imagine? Okay, Wikipedia is pretty good when it comes to definitions, when it comes to explaining technical subjects. I almost never found an error when he's talking about some technical things like math, physics. It's usually pretty good, and there are references, etc. Right? So if it is politics, if it is other topics of that, yes, Wikipedia is not always reliable, but for technical things, is good. It's a starting point, right? Just to understand some basic concepts. And right now, I don't see anything that can be debated. It's all simple definitions, so it's a perfectly valid source. So I'm I'm just giving this warning because I'm sure there is somebody who say, "Oh, he used Wikipedia. Can is not it's not a reliable source." Okay, it is for these kind of things. And here again, there is an example. Actually, if you go on Wikipedia, we have like a little animation that shows you, um, that there is something coming in, something coming out. There is a stock, etc. All very simple ideas. And okay, now this is where the concept of stock to flow comes in. Okay, and I thought for a long time when I was thinking about this quantity, why somebody would even want to define it? Because as a physicist, like I say, we are very used to problem like this. There are many different problems because it doesn't matter if here we are talking about capital and depreciations and depletion. The part of what we're teaching in physics is okay, what this looks like, right? Can you make like a physical model out of it? And this generalizing, you can apply to anything. You can be a star. There is gas coming in. There is the star is blowing out the gas. It can be anything, and if it has the same type of behavior, then I can describe it. And in the end, maybe I want to write some equations, to describe its behavior. So the way that a physicist will do will simply write an equation for stock, for example, right? Because stock depends on the flow and time. I can write an equation of stock, and then I can make a graph of how the stocks changes. If I have a question, if it says, "Hey, I start with this amount of grain, and I have an overall negative flow, right? Because maybe there is some production, but the depletion or the consumption of this good is higher than the positive flow, the production. Given this total negative flow, and assuming that it's constant, but it doesn't have to be constant, it can be complicated function. That is the beauty of doing it in this way. Then we have tools like integrals, etc., to calculate how the stock behaves in time. Or I can say, how long will it take to go to half of a stock, one third of a stock, running out? Okay, there are much better approaches, but somebody, I don't know why, because maybe we failed calculus. I don't know why they come up with this silly quantity of taking the stock and divide it by the flow. And why I call it silly? Because really, it's nothing else. And here we say the ratio of a stock over a flow as units of time. Why? Well, it's stock, right? That is a quantity. Let's say it's dollars, right? Because you're talking about capital or something. When you're dividing by the flow, that is what? Dollars per unit time, right? So it can be seconds, it can be days, it can be months, or whatever. So what happens? Well, units and the units here, like I say, it could be grain, tons of grains. It can be dollars. It can be liters of water. They cancel, right? When you do this thinking, when you're dealing with quantities that have units, you cancel the units, okay? And until you are left with if there are similar units, you cancel them, right? And then you're left with whatever is there. And so you know what this quantity is all about. Is it a force? It's a pressure? It's whatever it is. In this case, when you do the operations of simplifying these units, units and units go away, right? Because it's you're dividing by this quantity, and because you have like one divided one time, okay, simple math to show that basically times goes up, right? And all these is simply time, okay? Think about like if I divide it by one, divided by one, divided two, this 1 over 2 is basically zero point 0.5, and if you divide 1 by zero point 0.5 is 2, right? So basically time goes above, right? Comes up. Hopefully you understand what I'm saying here. So, but after basically simplify, you find out it's time. What does it mean? What does it mean? What the interpretation of that? And here they come up with. I, I don't think. I don't know if this is. I don't think that this can be qualified. This debt to GDP ratio as a stock to flow, because what you're stock in debt, whatever. But it's kind of a stock to flow, like we can call it like that, because there is some quantity debt measured in dollars, GDP that is measured in dollars per year, for example. And when you take the ratio of that, you get years. And then the interpretation, because now you have to understand years of what. So it says basically which yields the interpretation of the debt to GDP ratio as a number of years to pay off the debt. So assume a GDP devotee. So basically you're saying, this is what you're saying. If I have this thing, in this case the debt, and this is how much I produce, the GDP, and I'm spending all my GDP, that is unrealistic. Sometimes when we do this calculation, we look at an extreme case, like some unrealistic, because it gives you an idea, right? And then, of course, the realistic case is kind of a fraction of that. So you have debt, you have GDP ratio, you take this ratio, and it basically is telling you if you were not accumulating more debt, that is again unrealistic, but given the current debt and the current GDP, how long will it take to pay off all the debt? And so the answer you get in years is answering basically this question. So in general, this is how you want to interpret it. Like if I, like for example, Plan B was telling me, oh, how would you understand that gold has a stock to flow of 50? Well, 50 years, right? It's not just a number without units, as the units of time, years in this case. Well, what it can be interpreted as that there is this stock of gold all over the world, and if we didn't accumulate more gold, and let's say the current build up of gold, the current production of gold stop, and it became a negative quantity, let's say, then it will take about 50 years to run out of gold. Or the other way around, if we wanted to double the amount of gold in the world with the current flow of gold, so how much gold is produced, found, right, through mining, etc., it will take another 50 years to do that. Okay. And so, and of course, bigger this number is, means that in a certain sense, uh, it's more rare, right? Because it takes longer to accumulate or to run out of this quantity. And so, in a certain sense, like I say, I would not imagine a physicist thinking about. Okay, so yeah, I was saying, you can come up with a quantity, a silly quantity like the Santostasi, and it's basically the number of times that I mentioned bitcoins, and I mentioned power laws. In when I talk about Bitcoin, I'm dividing by the price of Bitcoin to the cube, multiplied by how many birds are flying above my house, right? The question is this quantity useful for anything? And it's related to something that we it's important, we can use to understand the world around us. If it is not, you can define anything you want, and then nobody will use it, and you know it's completely useless. So it's not a question of not being able to define something. It's a question of what do you use it for. Okay, but at least now we know what this stock to flow is. Hopefully, it's a little bit more clear, because I think it was not clear to me when I read it for the first time. I had to think it over and over again until I understood it. Because it's very non-intuitive. Okay, so the way that in physics we will do that, it will be more a calculus kind of thing, right? Where you have some kind of quantity like the stock, and this quantity depends on time, and then we do this operation that is called a derivative. It basically means you're looking. So it's if you didn't do calculus, all what this means is you're measuring the change of something over the change of time, right? So this is called a derivative, and you're trying to make this change both in time and in the quantity very, very small. So it's infinitesimal, what we call infinitesimal. And then calculus is all about, it was invented by Leibniz, by Newton. It's all about how to use these quantities to understand things that are changing, right? So for example, if I define this quantity, I know, so this will be the flow. This our physicists will think that is the change in time of this, the rate of change of this quantity, the stock. And then if I want to answer a question like, this question that we were trying to understand about how long does it take to deplete a stock, you will simply calculate, you will use this quantity to um, solve for time, right? So if you know how much stock you started with, and then you know how much the stock is changing, you simply solve this equation, right? It will look something like this, where you have initial stock, and then there is a change in that stock, and you can solve for time. Basically, I think yes, this is what you will do. It's called an integral, right? So if you know the flow, it can be positive or negative. How it's changing. It doesn't have to be a simple equation. It could be something relatively complicated. It is too complicated where you cannot resolve this integral analytically. What is called analytically, basically, you cannot find a formula, right? So calculus teaches you to find formulae that basically are solutions of these integrals. There are all kind of tricks and uh, steps that you can follow, but you can also do it with a computer. Basically, with a computer, you will not be able to do the infinitesimal change, but you can make it an arbitrary change. This is how we do almost everything today. With almost nobody tries to solve things, analytically. Sometimes even when you can, because it's so much easier to simulate these with a computer, where you look at small changes, and you can make these changes as small as we want, and then you solve these with computer approaches instead of with computational approaches instead of analytically. But you're still trained as a student to do it, because it's still good to know how to do it. But this is how you will think. You will think, okay, if I want to know how a stock changes in time, I can, and I have this different function. It could be like something that goes up and down. Then I solve these equations, and these equations have the same function that this silly stock to flow, because if I want to solve for time, I can solve for time. Okay, and it's this is why I never heard about this stock to flow as a physicist. I of course understand flow. I understand stock. I will not come up with taking this ratio. It's like the equivalent of taking distance over velocity. Nobody does that. It's there is no such a quantity in physics that I know. And if we use velocity, we use distance. So if a typical problem that we solve in physics is that given this distance, this velocity, how long does it take to reach this distance, right? But you will use calculus or some even algebra if it is if equation that describe velocity is not very complicated. You can even just use straight algebra and you will solve it. So I don't know why we do it in this way. It doesn't matter. Anyway, so um, yeah, and here is an example of of how you will do it. So, for example, if you have a flow, in this case, the flow is a complicated function, not complicated, but it's not a straight line. It's not a linear change. It's not constant. It's um, the simplest case is when the flow is constant, right? So, for example, if I'm producing, 1 ton of grain every year, and it's not changing, when I calculate the tons per day because I divide by the number of days. Um, but in this case, in this example, it's kind of complicated, a little bit more complicated because it's basically like the positive part of a sine function. And there is a certain time it takes to go up, then down, and they show here how given this flow. So you will, in this case, you will have to use your stock to flow will be completely useless because it's not a ratio. It's more complicated than that. You will have to solve this integral, and you will get a function of that describes. It's almost like one of these adoption curves. It's not completely. It's kind of almost looks like that because with the adoption is the same thing, right? Very few people adopt some technology, and then you reach a peak, and then the number saturates, and so it's kind of similar to that. But basically this is what you see, and what you the other thing here, they compare basically two type of stocks. One where the flow is negative, so you start with a certain value, like here 10, whatever that is, dollars, tons of grain or whatever. Then because the flow is negative, this red curve, it goes down, right? It goes down. It becomes negative. I think in theory you could define a negative stock by, I don't know, maybe debt, the equivalent of debt. Um, but uh, and so this quantity becomes negative, this quantity becomes positive, or you're digging a hole somewhere or something. If it is the height of a hill, and then when you reach the ground, it's becoming a hole. So it's negative. It doesn't matter. But basically, you see the opposite of each other because I think the flow is the same in size, but one is negative and the other is positive. So basically, they are kind of like mirror images of each other, right? And so it's a nice example. We have a table, so this is all from Wikipedia. You can learn more by reading that. Um, so this graph here, I want to go to the next step, right? So the next step after now we understand a little bit better what stock is, what stock to flow is we are moving towards the relevance of all these for understanding Bitcoin. And so I wanted to understand better what Plan B did and be more familiar. So for me, that means I'm going to my computer and I start to calculate stuff, right? I make like a little code. I use this language called MATLAB, and I make my little code. And I like to think from very, very simple examples, like what we call toy models in physics, right? So because I understand everything, I am in charge of this situation. I decide what is going on, and so I don't have to deal with external things because I'm almost like a little god in this universe where I decide things. Like what did I do here? Uh, I decided that I'm trying to model Bitcoin, right? This is different from when I'm trying to model it using real data. In this case, I'm trying to gain some intuition about what this stock to flow is. So I thought, let's make an example where the real price of Bitcoin, it's a power law. It's exactly the power law that we observe empirically, right, by looking at the data. But in this case, there is no noise. Like imagine a crazy universe where everybody's like a robot and buy Bitcoin in a certain way, and then the result is this beautiful power law, and it's perfect, and there is no noise. And the reason to do all that, even if it is completely unrealistic, is because it's so simple that I can see everything. I can understand what is going on, right? So this is a model, a very unrealistic but very simplified model of what Bitcoin is. There are no doubts. I made it so, right? You cannot tell me, oh, but this, but that. It's like this. I decided that it's behaving like this. And this is how it looks like, right? So a power law is basically like, it looks like a parabola. It's a very fast parabola because if you follow my work, basically the price looks like some kind of constant. That constant basically, all what that constant means is not the most important parameter. The most important parameter is this power. That power means I'm raising something to some number, right? It's called an exponent. It's called a power. And so these days are the days from when Bitcoin was created. So 0 here means January 3rd, 2009, when Bitcoin was created. And here is the price in dollars. I'm using the scientific notation, but I don't have to write, say he price dollars here, but this is mostly me playing with stuff. So when I do it this, usually I don't even worry about, writing down the unit nicely, etc. It's mostly for me to explore stuff, but it's okay for the purpose of this discussion. And so this is how it looks like, right? So if we had to plot it in a linear graph, it will look like a parabola. This is what the power law is. It's that simple, okay? It's nothing mysterious. It's some kind of very fast parabola. This is what we are saying. Even when we apply it to the real data, we say Bitcoin looks like a very fast parabola with this power. It's not a square like a normal parabola. It's almost like 6. And if you, I'm kind of a little disappointed. It's just like some curve like that. It's a magical curve because it has a lot of property that I discussed before, scale invariance, blah, 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 and so on. But this is what it is, okay? And then when you plot it in a log linear graph, this is a familiar curve, right, that we see from the rainbow chart, etc., with nice behavior of Bitcoin where it looks nice and curves gently. But why is a curve? Because it will look like a straight line if it was an exponential. If it went up like a hockey stick, it is another type of curve. In a graph like this, the middle one, what is called log linear, it will look like a straight line. And instead it doesn't, it curves because it's not a straight line. It grows a little bit slower. Even with this very high power, it grows slower relatively to an exponential. And notice there are no bubbles, there are no bumps, there is nothing. It's very, very smooth. And I did it on purpose. I could add noise, there are ways of simulating noise. When you do this calculation, I could add the bumps, etc. I just want to make the simplest possible price model where I have everything under my control. This is something that we do often in science, right? We do some very simple, like the simplest possible case, and then once I understood this, I can go to a more complicated ones, right? And it helps you to gain intuition about what you're studying. We call them toy models. And then, like you saw many times, again, if you're familiar with my work, if you take these things that look like, so this is actually a nice illustration. I'm glad I did this because many times people are wondering, like, how will it look? Your power law, if it was in a linear graph, it looks like this. Then in a log linear, it looks like that. And then we are familiar with the fact, right, that if I go to the last transformation, like a Pokemon in its final form, it becomes like this beautiful straight line. What looked curved before in different ways, up in a linear graph, down in a log linear, now it looks straight. It's the mystery of mathematics, right? But it's not a mystery, but why we could show very easily that this is the case. But we can do it in another video, etc. I can show you why you get all these different type of shapes and forms, even if you're dealing it's exactly the same equation, right? This price equal A times days to the 582. And I was telling you before this A, I think I didn't finish my sentence, that A, it's a very small number. So if you go all the way, right, to the, it's basically, it tell us what the price will be at day zero. And the price, it's basically 10 to the minus 17 is a very small number, that basically tell us that we are very close to the origin, that is zero. So basically the price was zero, right? Was zero when it was created. Okay, so I say, let's imagine in this toy model, the price behaves in this way, right? And then I'm going to calculate S to F. And I do exactly the same steps that plan B did, okay? So he defines this quantity, and this quantity is what? It's basically for Bitcoin, because Bitcoin is programmatic. This is where we start to get in trouble, because it's different from how we think about other stuff where maybe we have a complicated inflow of production, for gold, or maybe we have a very big stock that has been there for a long time. With Bitcoin, we started with zero, right? We didn't have any coins at all. And then there was a very simple function from the beginning that tell us how many coins are produced. I don't remember by heart, but I think the first year was 2 millions per year or something like that. But let's simplify. I use actually the actual numbers, but in this calculation. But to make a simple example, let's say that we were producing 2 millions of Bitcoin per year, and then we want to calculate the stock to flow. Remember what stock to flow is? You take a stock that in the beginning is zero, and then you divide it by the flow. But the flow is basically what we say. If we measure it in terms of years, right? How much coins we produce for a year is 2 millions per year. So let's say you wanted to know what is, because here I'm using days. This x-axis is days from the genesis, right? So I want to know how many coins per day I have. That is my stock every day. I take the production per year, I divide it by the number of days in a year, the 365, right? And that quantity now will be my rate of change of a stock. And to calculate what the stock is, I take this production per day that I derive from production per year, and I multiply per day, right? So basically, the first day you will have 1 over 365 times 2 million, whatever that number is, bitcoins. And then next day, now you have 2 divided by 365 times 2 million, and so on. By the end of the year, when the year is over, what will be a stock to flow? 1, because basically it's telling us, stock to flow, that it takes 1 year to make 2 millions, right? So this is what this silly quantity is. After 1 year, stock to flow will be 1, because it took 1 year to make 2 million Bitcoin at a rate of 2 million Bitcoin per year. After 2 years, guess what? What is the stock to flow? 2. After 3, you guessed right, 3, 4, okay, after 4 years. So after 4 years, basically the stock will be 4. Sorry, the stock will be, whatever, because every year we produce 2 millions, right? 2 million, 4 million, 6 million, 8 millions, right? Every year we go by 2. Again, I'm making this number simple, right? The real number was, I think, 2.5 or something like that. It doesn't matter, right? So make it simple, 2 million, 2 million, 2 million. But the stock to flow is 1, 2, but 1 year, 2 year, 3 years, 4 years. It's a silly quantity. It's telling us it took 4 years to build up to 8 million bitcoins, okay? Because we are producing 2 million bitcoin per year. You see, it's relatively simple. So if you ever wondered what stock to flow means, now I think you understand it. Okay, you should understand it. And is it useful? It's interesting. What does it tell us? So far, nothing. So far, absolutely nothing. Because what can we use it for, right? We already know that we are producing 2 million Bitcoin per year, and it's I can answer from the start what the stock to flow will be after 1 year, right? It what does it tell us? Absolutely nothing. Okay. And you can say, well, by the fourth year, we reach this number of four. That means if we stop production of Bitcoin and we were a consumption of consumption in which sense? Where is this stock? It's not that it's sitting in somebody's granary or somebody's bank. It's not a good quantity for describing Bitcoin. Yeah, you can calculate it, but why is relevant to Bitcoin? Bitcoin, yeah, there is a certain number of coins in circulation and people are buying. At the time, probably there were more Bitcoin than people wanted, because it was not circulating much. Probably there were more Bitcoin. People were selling 10,000s of Bitcoin for pizzas. It was flowing around. It was not like, scarce because people were using it and were bringing it around. So I don't think there was ever a time when Bitcoin was scarce. Tell me when it was scarce. Scarce means it cannot meet demand, and the demand is always there, and it always met. Wherever you can buy as many Bitcoin you want, it's just that if you want to buy a lot of them, the price goes up, and it will be more difficult to buy. But in theory, you can buy as many Bitcoin you want, until basically you run out of money. It's it's not that you're running out of Bitcoin, you're running out of cash. So I don't think it applies to Bitcoin as a concept. But okay, you can still calculate it. We say we don't want to be debating this issue of scarcity related to Bitcoin. I want to show you that anyway, this approach leads to contradictions. Okay. And so here basically this is what they did. So now what happens after 4 years? We have our first halving, right? So we have a halving that was this think that Satoshi program where the production of Bitcoin is anti-inflationary. So he wanted to create a system that was anti-inflationary. So basically the opposite of what the government does. Instead of printing more money, he wanted to reduce the flow of money. So we are still producing money up, until we reach the cap, but we are slowing it down, right? And so you can simulate that in a computer by basically dividing the flow by two, okay? And then, so what happens to the stock to flow? Well, the stock initially doesn't change because we are not producing. So let's say imagine the first day after the halving or the day of the halving itself, right? The stock is still there. It's the same as it was the day before. We didn't increase it, until the day is over, right? So if you calculate how many coins per day there are, right? But all of a sudden, the stock to flow jump because this code is going to, change how many coins are being given to the miners, and it goes down by a factor of two. So the ratio, because you're dividing by a smaller number, by a factor of two, when you take this ratio, the stock to flow goes up by a factor of two. So it went from being four, all of a sudden goes to eight, right? And then you start to accumulate. So you take this eight, and now the stock is eight. So basically, it's a phase transition, what we will call in physics a phase transition. So you have different options. You could, in theory, start from scratch and call this S to F2, and it will be exactly like before. But the other option is to say, okay, I'm going to add the previous stock, this, if you think in this old economic way where you have this quantity, it doesn't mean anything as a stock. It's not that you're running out. But okay, let's look there again. So if to be consistent with the normal definition of stock to flow. So you will take away stock up to this moment, and then you will do what you did before, because and now but the rate of change of a stock will be smaller, right? But you continue to calculate. So after basically 1 year, let's say it goes from 2 to 1 million now because you reduce the production. So you started with 4 million coins. Then after 1 year, you accumulate another million. So the total stock would be five. And now you divide it by a smaller number. So you know how it goes, right? So and so here I show how this stock to flow will look like. It looks like basically like a stair, right? Like a stepwise function is a technical name that we will use. And and any segment here is basically like a linear function of time because it grows right linearly with time, and this is how it looks like. And if you take, this is to compare with how the price looks like. I showed it in a linear graph, in a log linear, in a log log, right? So this is how the stock to flow will look like in a linear graph. This is how it will look like in a log linear, and this in a log log, right? This is. Now, what Plan B did next? What did it do? And this is something that many people don't realize, okay? Because we think we have a power law in time when there is the stock to flow and they have nothing to do with each other. But actually, no, because, oh, and by the way, this is basically like a zoom in of this chart where I have a log log of S to F. This is how it looks like, uh, as a function of time. So it's linear. It looks linear in the beginning, and then it's also linear. But now you see it kind of, first of all, why the segments became smaller and smaller, because when you do it in a log log graph, these times uh, they are all for years, but they look smaller because basically we are kind of compressing time. We're looking at changes in scale of time. So it looks to us like time is compacted, right? It's an effect of this, of using this log log chart. But so what did he do? This is what the next step, that because he calculated that quantity, right? Like exactly like I did. He went through, probably using a computer. He coded it, and he created a quantity that looks exactly like that, right? Then he took that quantity on the computer and he plotted versus time, but it took both the log of S2F on the x-axis, and it took the market cap. You can do it with price. There was some debate about, you probably don't want market cap because market cap is also a function of stock, so it's a tautology. So I agree with the Plan B. You can avoid these. I'm not using these because this is what he had in his paper, but you can just do price, right? But he did it with market cap. Doesn't matter. But basically, I'm trying to reproduce this graph here. This is from his paper, his main paper when he came out. And as you can see here, so I did this, right, and it's all clean, all without noise in my simulation, because this is what I started. I started with a price. It was beautiful. It was clean. It was this power law. There are no bubbles. There are no bumps or anything. Uh, so in theory, there are no jumps, right? Because this is what motivated Plan B to come up with this idea that these bubbles are due to these jumps in the stock to flow. But there are not. So you know already that where I'm going, that there is a problem if I try to model it like that, because there are no jumps. What I'm trying to model there, right? Okay, so um, yeah, so this is basically what he did, right? Just a second, I'm trying to find it. Okay. And let me go back to this. Okay. So this is what he did, right? So, and this is like I was saying, many people don't realize that this was one of the fundamental steps. So first he calculated S2F based on the definition, based on this idea that there is a change in flow every 4 years. So you can calculate, you can create a synthetic, and this is the only way to do it, right? There is not that there is an observable, maybe there is an observable by, you could do it based on also on block. I think he added that block time instead of real time to make it probably more realistic based on the real production. But it doesn't matter. It doesn't really matter. So you can, uh, you know, do it synthetically or do it more based on real data. But it will be still very similar, right? The only thing that changes is the block time versus the real time. Um, and so you will see a little bit more noise there because of this time is not exactly like real time, but it doesn't matter. So the important thing is to understand this step is, and here I don't know if he had an intuition. I don't know. Part of me, I think I asked him that question. I think he was aware of my idea of plotting price versus the log of time, log of price versus of log of time. But other people did something similar also with other on-chain parameters. They were published papers. Like I was one of the first people, I think, to show there was a power law between addresses and price. It was a power law between hash rate and price. There are power laws all over the place. And other people follow up. Like, I always say there is this paper from one of my favorite physicists, Ornette, where they talk about exactly this thing, addresses versus price. And they say that it's supposed to follow Metcalfe. It is a power law because it's address the price equal address is square. Every time you have a power like that, an exponent like that, you have a power law. But then it turns out when you really measure it, is they say 1.7. When I measured it, it was early on. It was actually 1.5 and changes slightly, to 1.7. But you can, I'm pretty sure that maybe he was aware there were a lot of power laws. So maybe he had an intuition. I don't know what motivated him to see if it was a power law. You can always try, right? You can try. If there is a nice, beautiful straight line here, you can make the assumption you're dealing with a power law. That there is some kind of scaling, because that is what you're after. You're not after about, oh, I'm trying to do some regression. Oh, it's really an important thing. It's if there is a relationship of that kind, probably means something. There's something deep about how price relates to this stock to flow. Like in this graph here, see, you call open scarcity. Scarcity if in this case if a flow goes down, but even there. But again, no philosophy. Let's do the math. Okay, so he does this, and I did it. I did exactly what he did. I plotted my artificial, because remember the goal is to make everything simple where everything is artificial, because I'm not getting confused by the noise and by other things. Everything is under control here. So I take this artificial, and when with that artificial, it means I follow exactly the definition. I follow exactly the same. I use the same numbers of Bitcoin produced per year, like in reality. The only thing that is missing is noise. Okay, so it should be exactly like we see with real data. The only difference, because it's so simple, we don't have these bubbles. Because I did it on purpose. I didn't want bubbles. I want to make it smooth. So this is what you get. You get something that kind of looks like what he has. I'm not sure why this straight line, when he draws it, goes through these points. It's something that I want to understand better. It seems to go through this initial point. These initial points here that you see that go in a straight line in this graph, Um, the graph, this graph is the one on the right, right? We use these nice color dots. I think he does it for every month, and the color represent, like he has that little, this colored, color coded bar here, that basically the months until halving, right? Then you will start at zero when you have the halving. So you notice how the colors change from being 40 months, then it comes closer and closer until basically you have zero. So that basically means the first halving. So all these points in a straight line are the before the halving. There is a deviation from that straight line that was that big first bubble that we had, like thinking around 2010. But in general, they seem to follow a straight line. I don't know why my model doesn't reproduce exactly that. It's something that I need to look it up. I don't know if there is something wrong in how he did it, or if there's something. I don't think there is anything wrong in mine because it's a very straightforward calculation. I simply reduce. I calculate it like that way, where I multiply by this constant rate, and then the moment that we have this jump, I made the S to F jump by a factor of two by reducing the supply, by reducing the supply rate. So, if anything, mine is actually closer to the theoretical calculation and how it should be than what he did. But maybe there is something that I'm missing, but it doesn't really matter. What matters is you see something that behaves more or less like a straight line. We both have that. And then talking about the regression line, where the regression line goes to its point. I could have done it in that way, where I force it to go through these points, but when I calculate the regression, it tells me maybe because you know what it could be because I think I know because I have more of these. I think now I understand it. If you have more of these intervals, like he has only two halvings, I have four, and so these subsequent. Yeah, I think now I understand. I think actually you see sometimes thinking aloud helps you. So my line, it's more inclined because I have more halvings. So the regression gives some value, right, to these points further on the other halving, and so it looks less steep than his line, and so it doesn't go through these first initial points before the first halving. I will redo it with only two halvings and see if he looks more like he is. Okay, but you see actually what happens that nice, beautiful straight line that he has, it starts not to be that. In fact, I never saw another graph like this produced by him, right, by Plan B, after the third halving, and of course we don't have yet the fourth halvings, and so we will have to see how it looks like. But it will be interesting, right? We can always go back and do it with the real price. That is something that I want to do. I did it before, but I can show you when I do it real versus synthetic data, made up data, how it looks like. But you can see there are similarities, right? For example, I call them blobs. So first you have these points, then you have like a big blob. That big blob is when basically when S2F jumps. And there is also this compactification. So the same compactification that I described before, because now we're going up in terms of tenths, in terms of scale, you see here. But it's a little bit confusing because, there are the bubbles, there is some noise. But you can see it. I draw like these circles. They are separated. Now, when you have something like that, it's always problematic because it is true you can pass a line to anything, but in theory, let's say I have only two blobs, I can always make a line going through blobs because that blobs they work almost like one big dot, one single point because they are so close to each other in terms of the x-axis that you can almost consider it like one single point. And there is always a straight line between 2 points. So if I even if I had like completely random data and I draw the first two data and it's part of something that is a mess, I can always draw a line through them, right? So you have to be careful about these kind of things when you do these regressions, etc., and trying to understand what you're doing. Well, so we don't have this problem with the power law because we take all the data. Sometimes I do that later when I try to understand better. Sometimes I throw the bubbles, but even there, when I throw the bubbles, and I say it's not the main analysis I do. When I do the main analysis, I keep all the points. But even when I throw the bubbles, and I want to do it to see what's happening between the bubbles, I still have hundreds and hundreds of points, right? Sometimes, the bubble creates these gaps, and that could be a problem, but they are so perfectly aligned, and I use a lot of them. I could actually also take averages, instead of throwing the bubbles. And, I don't throw the bubbles randomly. I use some statistical methods to do that. But here, the bottom line is that you can see my drawing in my simulation looks more problematic, right? It's kind of silly almost, like to draw a line between these blobs. It's kind of, yeah, you can do it, but it's really a bad fitting, very a bad fitting. It's horrible, right? It's already a problem there. Like, it's not like you will not look at this and say, oh, look at this beautiful power law, like it in his graph looks like, right? I think it looks like that mostly because there is noise that confuses a little bit things, and it just only two bubbles instead of having three or four like I have. It puts gold over there. Okay, it seems kind of a line, and people criticize that, and yes, also silver, because they say, well, these values are not constant; they change all the time. So you can maybe pick up a value. I don't know if you took an average or whatever. It's interesting. Maybe it's worthwhile to explore it. Maybe there is a power law. There was a time when actually I spent a lot of time, like several years ago, when the model came out, to investigate these things myself. And I got like a downloaded gold data for many years, like I'm like even 100 years of data or something like that. And I started to see actually some interesting pattern, but we can discuss it another time. Maybe there are power law that tell us different type of commodities, etc. But Bitcoin, I don't know. I think this is forced, and again, it's not. It's it's interesting, and you can do it at the same time. Given what I'm seeing here on this left graph, that basically is kind of something is wrong. By doing this force log, and I don't see a power law at all because I see these segmented blobs. That is basically time. We are distorting time. This is all what we are doing. It's time in between each halving, but we are adding, the previous stock. So now it's like stock time plus a constant. This is all what it is. So this is problematic. Maybe with gold and other more organic things, there is some meaning there. But with Bitcoin, because that's like a code, you already see it's kind of garbage. And notice a few interesting things. First of all, the slope, right? So when you see this number here in his equation, he writes it in his way where basically it's the log of y times some constant that is basically the slope. The slope, remember, is the power of a power law, and some plus the constant. It is also weird because remember this number that we are adding is supposed to tell us where the line meets the the y-axis, and so that is zero when the stock to flow was zero. When the stock to flow was zero, because the stock was zero, and that is 14, so it actually really means 10 to the 14. It was 10. I don't know. I know. Sorry. Was it 14? Yeah, it was. Yeah. So it's even that number. It's weird, because uh, when I do it with the power law, that number is actually a small number. Here, instead, is a positive number instead of being a negative number. So I don't even understand it. I don't. I need to go back and check that number. But what is important is, and is in, I think it's because basically I'm doing what I'm is doing with simplified data. I get the same slope. I get 3.34, and he gets 3.31. Okay, and the other thing, he gets 95 basically for r square. R square is this measure of how good the fitting is. It's a very many people, some that have some stat background, etc. Criticize. Sometimes they criticize my model. Sometimes they criticize. They are used to criticize S2F because unless you are careful about what this R square means and how you calculate it, etc., it can be misleading. And it's misleading here because you have these blobs, and the blobs make that number be bigger than it should be. Because you can see from my graph is really bad fitting because there is not really a straight line. You cannot say there is a straight line. There is kind of a linear trend. It's more like a trend than really like a nice, beautiful straight line there. And not even from, like in my case, when you do it with time, you have these bubbles, right? And the price goes down. So it's at least oscillating around the trend, right? So in that sense, you can say there is like a general straight line that represents the average. So in fact, if you take over and over the average, like a moving average, you can see that the price, the bubble gets flattened and the average starts to tend towards the power law. In this case, no, like this one blob is a little bit below, the other above, it's not nothing symmetric. It's garbage. Okay, it's really garbage. Almost everybody will agree with me. That has any math background. And then what do you do? So he says, so notice my R square is also amazing, even if the model looks garbage. And then because of this effect of it's almost like a leverage, right? So you're giving a lot of leverage to these blobs, but you would like to have smooth data. You would like to have sparse data. Like, see how it was nice before the halving, all these dots. That is what you want. But if you start to have blobs, it's problematic. What is the interpretation of R square here? And I get it. Also, very nice R square from this artificial garbage of data. As you add more and more halving, the fitting of the power law becomes worse. And like I say, I never saw Plan B showing something like this. Okay, and you can see what happens. I can do it. In theory, I could add 15 different halvings because it's all artificial data. So I can say, okay, this is what happened when X halving, X halving, and it will look even worse, much worse. But anyway, uh, with at least four halvings, the next one included, it looks like this. And then I say, okay, I see this power law, even if it's garbage, I'm still go ahead and assume that there is a power law. So he's saying there is a power law. This is what many people miss. There is a power law between stock to flow and price. This is his first step, the initial step that he does. It's an essential step because if you don't do this step, you don't know what the relationship between stock to flow and price is. He's making an assumption that is a power law. Okay. And to me, differently from what I do with price and time, it doesn't look striking. It looks like garbage. Okay, and how will it look like if I did it with price and time? It will look because it's an artificial situation. It doesn't. There are no bubbles. The straight line and the price will be on top of each other perfectly, and I will get an R square of 100, right? Or one, right? So 100% fitting. Because everything is under my control. I made it in that way. And but so I go ahead. I've calculated my A, my intersection like I did here, and basically, so he expressed it in that way. right? But if you use the math of logs, you can show that you can rewrite this equation that he has in terms of log. I can rewrite it in this way. I can rewrite it as price equal A times the stock to the power. So that slope there becomes my power, right? And very close. Notice how close these numbers is. That shows you that I'm doing exactly what it's doing. I'm calculating. I'm going through all these procedure, all these steps, all this math. I'm doing the same type of calculations, just with simplified data. Now, this is how it looks like. So the next step is what? Now that you know how the price relates to stock to flow, and given the stock to flow is a function of time, you see how it changes in time, right? It does this. I can go back with my computer and say, now plot me this quantity that you just calculate, right? Because I can plot it as a function of time, given that stock to flow is a function of time. So that is the second step. So I plot my theoretical, so here I call it power law in time, but it's also the price. Because remember, I am in this artificial situation where my price is my power law. I made it so. Instead of saying it's a model, I made this silly artificial situation where is exactly the power law. And you can see that his model, the stock to flow model, and it's very familiar. I remember when you look at his paper, it looks like this staircase, right? The staircase is following perfectly my model, but there was no scarcity. Scarcity didn't come into place. There are no bubbles. The two things are not related to each other beside being both functions of time. And somehow this quantity S to F is following very closely my artificial price. What is going on there? And you could say, oh, Giovanni, is because the power law that you found is really due to it's the other way around. The real law is this jumping of a price due to the this this scarcity thing, and you just approximate it, and basically you're coming close to the real behavior. Not really, because I went back, I changed it 5.8 to any number you want, 2, 3, 4, 5, 11, 3 quarters, any number you want, and I get always this, always this. And in fact, I can show you. So first, before I go there, I show you. I can show you different graphs, but let's see if I have a one that I want to show you. I don't have it here, but I posted it online where I did different things. I should have added. I thought I did. So here is another graph. Now here, what in this graph, I can maybe pull it up. I can show it to you from my X account. But here, I actually, so this is completely synthetic. And now I'm adding in this graph here, I'm adding the real price. So the real price is blue, right? See how the power law goes through that line. So, this was in my previous example was the artificial price. And you see how well the artificial price, that now is the model, right? It's giving the general trend of a real price. And you can see, like our stock to flow model seems, see, this is another thing that people, I think, like about the model, because they seem to be somehow, it gives the illusion, and you will understand in a moment why it's an illusion, that it's somehow related to these jumps, right? So every time there is a jump, there is the halving. This is where the halving is. And Plan B will tell you, "You see what happened? There was it creates a narrative, right, around this idea. See, there was the halving. The price didn't maybe immediately react, but it took some time, and then because if you zoom in, maybe it took some time for that, and then it was the price started to go up, very fast. And so you see how it reacted to the change in stock to flow. I have a beautiful model that is based on some cause. That is what really fascinating people. Like, oh, look, he found the cause is scarcity. It's bullshit. I'm telling you why in a moment. It's complete bullshit. It's an illusion. And and then okay, I think next happen, and so on, right? What is not an illusion is that these bubbles are somehow related to halving. That is something that I admit. They seem to be very regular. They happen after the halving. They happen every 4 years. So somehow are related to the halving in a very complicated way. Not the way, that is what I'm trying to say. Not the way that stock to flow claims. Why? Well, different things. First of all, and I don't have that graph, right? I wanted to show it to you, and we can go there. And maybe I can pause and find it. But basically, imagine, right, going back here to my artificial one, that now I change. So first of all, you can see here there are no bubbles. So you will never look at this red one and say, oh, that is a fantastic model, because the real price is a straight line. So it does a very bad job in following a straight line. It follows it. That is one of the clues here, that is able to follow, but there are no bubbles. So what the heck is this stair thing representing? Nothing, right? So it's already a problem, but it does this job of following. So it shows that it doesn't have anything to do with scarcity or nothing. There is no argument for scarcity here. But worse, I could, instead of price, now I'm simulating a falling object. You know what a falling object equation is? It's basically 1/2 g, that is the acceleration due to gravity close to Earth, times t squared, the time, right? The time that passes after you drop an object. So if you want to measure the distance covered by an object from the place where you drop it, that quantity it's basically a power law. It goes with the square of time. I did that. Okay, trust me. I posted online. I can do that, and all and behold, if now what the halving, what the flow is velocity, the velocity. So I didn't change anything. I just changed the power. I made it. I go from 5.82 to square to represent the falling of an object, and then I change the velocity. Basically, I didn't change anything. Actually, I interpret the change in flow as the velocity, because this is what is. If now we're dealing with distance, the change in flow is not how many Bitcoin we are producing, but the change is the velocity, is the change in distance that is the velocity. So if I reduce the velocity, in fact, actually is weird, because as the object falls, the velocity increases, the real velocity increases. But in my model, I reduce the velocity by a factor of 2. But it's completely nonsense. And hold and behold, because this happens every time. It's not just a special case for 5.8. It happens every time I change the power. I get exactly this. So if I get exactly this, and now we're talking about the distance covered by an object and not anymore price, how is possible that S to F, or something that is S to F like, because now we're talking about distance and velocity, tracks my motion of a falling object that will look like exactly like the black curve, but now with a slope of 2 instead of 5.8. Don't you think is a problem? It is, because the reason why S2F does this has nothing to do with scarcity. Let me repeat, it's not philosophy, it's not a worldview, it's math. And there are very deep reasons why that I will cover, because I right now want really to focus what the, and it's a little bit more technical, and so I don't want to go right now there. But it has only to do with basically how the quantities is defined, the fact that Bitcoin grows in a very predictable way. So when you add all these things, it turns out the bottom line that I found out basically is that this model of S2F, from how it's defined and how it's built, can fit anything that looks like these power laws. In fact, not just power laws. Usually power laws is only x to some power, very simple. But there are functions that are more complicated, where you have, let's say you have a 3 to the x squared plus x to the 3 quarters plus uh, 9 times x to the 9, whatever. If it has that format, that it's called a polynomial. Polynomial actually need to have integers, etc. But anything that looks like that, uh, with a bunch of x's to the power of something, and you add them together. So even something complicated initially, and this, remember, initially means here we have only 4 halvings. So if you do this only for few halvings, it's going to fit anything. It's going to be a good model, like quote unquote, of these equations, this type of equations. And so that equation can represent anything. If it is a falling object, what has to have has anything to do with a falling object? Nothing. And still you get something that looks like this. So you can see there is a serious problem. And the fact that you synchronize it to the halving, it's NACOL, is an illusion. And I don't claim that Plan B did it on purpose. Sometimes you are the first person that get fooled. This is why there are many times with my models, I wake up in the middle of the night thinking, am I right on this thing? Am I wrong? Did I do something stupid? You are the first one that can get fooled by these kind of things, right? So Plan B is a great guy. I'm not saying anything negative about him as a person. It can happen. It can happen to anybody. It happened to me many times in exploring things. Like, this, that was really stupid from me to do that, right? He didn't, maybe got excited. He got excited by, whoa, look, and if I did the same and I had the same intuition, I would have been probably in the same boat. I would have been very excited. I have a causative model. I found, something that has economical sense, that is intuitive for a lot of people. It's not intuitive because we already saw how this quantity is so silly and it's very difficult to even interpret, etc. But many people think they understand it. We have this illusion that we understand it. I synchronize it with this halving, and it seems to be correlated with these bubbles. So it gives this illusion that there is some magical explanation that I found, that this model has some powerful explanatory power. And this, I think, what made this model so incredible popular. It was on Forbes. Everybody was talking about. Some people started to attack it. Most of the attacks were, these economist people looking at, these mathematical tools, that I like intuition. I like to understand things. I like to go to what is going on, what is really going on here, right? And there is an intuitive understanding of why this happened, but it requires, it requires some little math. Okay, it's the key. I can give you a clue, and then we can explore it later. If you did some little calculus, probably you almost immediately understand what I'm talking about. If you didn't, it's a little bit more complicated. uh, and I will try, when we go there and I try to explain you why this happens. I will try to make it as intuitive as possible, okay? Because it will help me also to understand this concept better. But basically, the clue is Taylor expansion. It's, in a sense, we are doing, by making these steps, we are doing kind of an approximation where we are adding more and more terms, and we are seeing the end. And this is one of the graphs I do have, where it is. Yes, here. If I continued to do these jumps, and this comes from one of the article from H.C. Berger, that is, one of my collaborator. He took, actually, his contribution was that he read my article on Reddit, and he made the model popular. He did this series of articles that are very well done, very well thought. He goes through all the math. He understands the model. He doesn't push much the philosophy of it, but like I'm doing, but he's very good with the math. He did a very good job. And here we can see how the S2F looks like. First of all, you see how it doesn't do a very good job in the beginning at all. So that so many times is forgotten, but uh, and okay, but we can, you know, go beyond that because it's supposed to be a model that tell us how Bitcoin behaves after the halving. So let's not think about what happened before the halving, but it's a limitation. While the power law, like I don't know if the other day I was showing some of the earlier transactions and the power law went through them through, they came very, very close to some of the earliest non-transaction dollars when people were selling uh, $1 for 10,000 bitcoins. But let's forget about that. Then you see it jumps, right? Like I say, it's supposed to jump at the first halving, and it looks like whoa, it's we don't have a third halving here because it's a relatively old article. Whoa, it's really something is happening there, magical, etc. But if you continue, the power law will continue like this, right? And the S2F starts to go away, right? In fact, probably we'll need maybe we can see a difference this halving, but even more the next halving, and so on. And then you really can start to see the two model diverge, right? Because it's a well-known fact that if you have something and you make it grow at a very precise rate, right, that is these 4 years, then because I remember what happens, right? The S2F changes by a factor of 2, but because we claimed that we found this very bad power law between stock to flow, right? Remember here, there is this power law between stock to flow and price. If you take a change of 2 to the 4, you get basically 10, very close to 10. So the idea will be that every time there is halving, the price goes up by 10. And if you do this over and over and over again, you get an exponential. In fact, because of a 10, it's an exponential that goes very fast. Like, for example, where we say that Bitcoin is like a million, by the time it's a million, according to the power law, we're talking about 100 million. 100 million when, according to the model, I don't know which one is more realistic. You do the judging, but the point is that I was explaining why we have these, why they look similar in the beginning, or why we can track the price so nicely, even when the price is artificial and is supposed, because we if in my example, because you can still say, well, yeah, they track because your power law doesn't work. The real model is the yellow line, and so it is you that is approximating the real model. No, because in my example here, right, in this example, is the other way around. I made it so they say it is like this, and then they say, well, you know what? It's not even Bitcoin; it's a falling object, and it still does this, at least initially. Now, eventually, it will go away, but initially, it doesn't. And it has staircase that, in my example, don't mean anything, both for the price because there are no bubbles, but even less for the falling object because of what the falling object, what scarcity can now explain gravity, the scarcity of velocity. There is a scarcity of velocity. Therefore, it does. It's even there. It's a bad idea because when an object falls, the velocity actually increases. But by some weird math in this model, the reduction in velocity by a factor of 2 makes it track perfectly. And I can tell you, I have an explanation, mathematical explanation why that happens. But you can see that it's showing that this model is complete garbage. It's no philosophy. It's no data. It's just how it's built. It's in the math. It's in the computer code. Not because I made a bug, but how is defined. Because I didn't make any bug. I can reproduce exactly in all the details what S2F did. It's not a question of bugs, it's a question of concepts. And in fact, even worse, you know, I can I made a joke where I can do something else, right? Where now I make the flow go up. I create a model where I go back to the equation and now I modify them relatively to what he did, because first I wanted to reproduce exactly what he did. And then I say, what if a flow went up instead of down? Right? That is exactly the opposite of what he was trying to show, what Plan B was trying to show, that somehow scarcity has anything to do with this to F. So again, it's not philosophy. We're not arguing if anything, if scarcity plays a role in how the price change, but for sure his model doesn't do what it's supposed to do. It is showing that scarcity does something to the price because it has nothing to do with scarcity, because it can the same model can be applied to a falling object where there is no scarcity. In fact, scarcity has a complete no sense. But then you can take his model modified where now it's all about abundance. So I made a funny Medium article copying exactly his title and say Bitcoin model, the scarcity model of Bitcoin. Okay, I made a model based on abundance. And I could write an entire article almost word by word, copying his wording, and almost like a joke, and paraphrase what he said. And every time he put scarcity, I put abundance. And in this case, because I was really trying to make a meme, I can say is abundance of bullshit during a bull market, in particular, bad calls from Kramer that they became bigger and bigger and more as the bull market goes on. And so the only thing I changed, I kept everything the same, exactly the same. The only thing I changed in my code was now double the flow instead of reducing it by a factor of 2. And this is what I get. This is the graph that I get. That actually to me looks nicer than his staircase model, but you still see this kind of staircase. But look at this, where what I did here, I did kind of illusion. I play with the illusion that he has. So I synchronize them in such way that the bullshit, because it makes sense, right? The bullshit is going to reach a peak when the price reaches a peak. And so I synchronize, the first, because I'm saying, it's going to happen 1 year. I think it is what I did. 1 year after the halving. 1 year after the halving, the peak of the bullshit is going to reach a maximum. This is when the doubling happened. There is like this sudden change in production of bullshit, and there is like this big jump, this discontinuity, and everybody starts to Kramer goes crazy and he doubles his production of bullshit, right? Of bad calls and whatever. And this is what I get, right? And it's a better model because it can tell you when the peaks are, it can tell you when the bear market, just after that happened. It's a beautiful model. And look how it tracks, the power law now looks, because I'm plotting it in this log linear, the power law looks like that curve, right? Through the data. But, my bullshit model reproduces perfectly these bubbles and their periodic model. So if you didn't know anything, in fact, actually, when I posted I didn't say bullshit. I didn't make it clear it was a joke. I just say the model based on abundance, on FOMO. I said, and people think, it was like I pretended almost like it was a serious thing. And I had a couple of people saying, "Whoa, this is amazing! We can use it," and they were serious, right? Because I had to correct them and say, "Look, I'm joking." And so these people were thinking that we really can use FOMO to actually make predictions of the behavior, because it has this illusion of being synchronized with this. It's not that I cheated. I just only thing I did was I double the influx of bullshit instead of reducing the amount of Bitcoin produced, and because I wanted to see, does it work also when we are using abundance instead of scarcity. And I say this happens instead of happening, this sudden change, instead of happening at the halving after 1 year, because it takes 1 year, for the FOMO to build up. It's just like an hypothesis, right? Like it has the same value of a hypothesis um, of plan B, where he says, there is this change in stock to flow, and that causes the price. Like many times he says, right, tells you, oh, but the price takes some time before reacting, and so they come up with some story why the price doesn't jump immediately. And so I came up with that story too, that after 1 year of the halving, the FOMO reaches an extreme, right, and it jumps all of a sudden. Look at this. It's a beautiful model, but it's bullshit. Do you get the message that I'm trying to communicate? This way, how stock to flow is defined, the fact that we are dealing with an underlying model, an underlying price that kind of follows a power law, the type of equation that this stock to flow is built on can track very well this type of behavior and gives that illusion that has anything to do with these bubbles, because it's part of how the model is built. It's all bullshit. It has nothing to do with scarcity, because otherwise, you know, I want a Nobel Prize because I just found out that scarcity of velocity, or whatever that means, has anything to do with gravity, like what I showed before. And also, everybody should start to use my model, this red model based on Kramer bad calls, because look, I think this looks actually nicer than S2F, the normal S2F, plan B S2F. I think this is a very powerful case. And just to give you an idea of how different it is. So, for example, so now we go back to the power law, right? So this is the power law. What is different? Well, when I do this straight line, to me, this looks a straight line, right? We graph down underneath. It looks like a straight line. And the normal type of straight line that I draw is actually a straight line through the middle, right? So that is the first approach that I have. And sometimes, just to explore different things, I draw a straight line through these blue points. The blue points, in this case, are selected by eliminating the bubbles, and I do it in a scientific way using what is called a ransack, etc. And you could argue, say, but Giovanni, you told us blobs, but these are blobs that are not blobs, are along the straight line. There are hundreds of points there, and yes, there are some gaps, but if if it didn't align so nicely, I would be a little bit worried. And maybe we can argue, okay, this is good, this is not good, to me, it's obvious. Look at this, it looks like a straight line. And there are other ways we can do it. Instead of doing it this way, we can take averages. I show another graph where if you take averages, over months, for example, these bubbles are smoothed, and then you start to see that there is a nice straight line. You can calculate. I did it like hundreds of different ways. I calculated error bars. I did it other ways where I don't even draw straight lines. I just take random chunks of changes in price versus changes in time, and then I never show that method. I actually have a Medium article about that, where I can do it in a more sophisticated way and still show there is a power law there. Okay, you can do it 100 different ways, and I would like to have this discussion with serious scientists and tell me, maybe this is okay, this is not. It's obvious that it's telling us something, that there's some kind of scaling properties of the price of Bitcoin. You can do it by hand. You can look at different periods of time, where, okay, how long did it take Bitcoin to go from $1 to $10? Okay, look at how long it took to do that. Go to the next step from $10 to 100 time. Okay, how much does it seem to follow this progression that I'm describing in terms of scales? Yes, you can do it by hand. Okay, you don't need a very sophisticated method. There is something there. Now, what about this model where I kind of follow the bubbles? That where I tell all the time, and I'm trying to be honest, it's a little bullshitting too, because how did they do it? Well, I'm saying I see this periodicity. They seem to follow for years. I kind of align the first bubble. I use a sign, and the beauty of that is, there is no stepping. It's not part of the initial model. It's just something that I add on, mostly to show where the bubbles are supposed to be, and I need just to synchronize the first one, and then the other come from the periodicity. So add any. I didn't look for the next peak, change around. I just say, look, may put the other one 4 years from now, from here, from the first peak, and so on and so on. And then the decay is modeled by the observed decay, because it seems that these peaks are becoming smaller and smaller. You can plot in a graph, uh, like if there is some kind of a pattern, it seems like actually it's an exponential decay, and I model that to is part of equations, and then you can see that that decay takes care of the next peaks, the second peak, the third peak. We will see if it takes care of a fourth, right? We can see, because we can project it and say if a price is decaying in that way. Now, what about this first bubble here? Many times I don't even show it there. I did an exercise where I just simply, this is really cheating. I admit, because I wanted to see, we can do something to mimic all the bubbles. So this one, because it's not due to any precise periodicities, I needed to put it basically by hand, but the other ones, no. All what I did was, okay, we see these. I could have even said the same thing. I say the first bubble happens about 2 years from the peak happens 2 years from the halving, or 1 year from whatever it is, right? And then everything else is taken care of. But I always say that is a little bit cheating, or it's just a visual aid that helps us to tell us when is the next peak is supposed to be, if it continues to do this periodicity. So, but I am honest, I'm open in saying this is not really like a strength of a model. What is beautiful, I think, instead, is how the model can track very nicely the bottoms, right? It does much better job in tracking the bottoms and the overall pattern. So, it's a much more honest model, and much more intuitive, and much more open. And in terms of the goal, is trying to tell us, is not introducing any causation that some people could say, but that is a weakness of a model. If I really found the cause of what is going on with Bitcoin, then I will be one of the most famous people in the world, and I will be able to explain so many things about Bitcoin, but I didn't. I just see these irregularities, I try to describe them, and I don't make any assumption. It's what is called, there is a name for these kind of things when you do it in science. It's called a heuristic model. That means you base it only on what you're observing. Basically, what Kepler did when he found a power law between the distance of a planet and the time that it takes. He didn't know what that was due to. He just reported that he saw this beautiful regularity, and then other scientists came about and tried to explain it. But I think that anybody that comes with a causative model for the behavior of Bitcoin needs to do it by finding something that is independent from making a graph that is based on a relationship between a quantity that changes in time and price, because you get in this trouble of having something that is driven by time versus another things of time, and then claiming that the two are somehow correlated. And people make fun of it all the time, because there are these graphs where the number of pirates is somehow related, to the Apple stock or whatever, the pirates in the war. I don't know if you ever saw these silly graphs like that, because you can find a lot of spurious correlations like that, and there are tools to study, analyze them, but you get in trouble. The beauty of doing it with time, if time is, it's not like some kind of function, is a clock. We don't control it. it it's this quantity in physics that is different from any other quantity because it's not a function itself of anything. It's just this continuous clock, right? When of course there are complications if you're traveling close to the speed of light, if you're near black hole or whatever. But let's leave these sophisticated things. The normal understanding of time is that it's something that happens and you don't control it. So this is why it's silly when there were these economists that were trying to do this sophisticated method to see if it was co-integration between. It's idiotic. It's something that it doesn't have any meaning to do the co-integration of time with price, right? It's just we are saying it's a very simple statement. We are saying it looks like price organizes itself over a very long range in a fashion that reminds us of these scale invariant systems. And there are many that have to do with time. For example, with the growth of organisms, the growth of teeth, the growth of horns. So somehow it scales up, all these different mechanics, different dynamics, social dynamics, market forces, etc. come together where this big, huge system that is open to the market 24 hours a day, many people interact with it. It seems to behave in a very regular fashion. And this regular fashion has some important properties like, is not going to change for the future, it's going to be stable, all of the things that I mentioned. But basically, this is where I want to end because I want to, basically, I think I made my case of showing that there is something seriously wrong with S2F. Later on, I can make a video explaining why it behaves in this way. But you can see it's not about philosophy. It's not about understanding the role of scarcity in Bitcoin. It's just how it is defined, how it is constructed, how you're going to code it, that gives you all these paradoxes. And it looks like it's doing a good job in following this general trend, but it's not because it can follow the general trend of falling objects. It looks like it does a good job in predicting or being connected with these changes uh, in the uh, in the flow that somehow have to do with these bubbles. But it's a garbage because I did it with Kramer's. Of course, I don't know. Like, in fact, so people tell me, how do you know how do you calculate the number of things, the FOMO, because in the beginning I didn't use Kramer, I say FOMO in general, right? Are you using volume? No, I just made it up. I just made it up. I just made a claim that FOMO reaches a peak 1 year after the halving, and I get this using all the equations, the only thing I changed was when this happened, instead of happening at the halving, it happened 1 year later, and I doubled the change. In this case, this quantity stuck to FOMO or stuck to Kramer bad calls, whatever you want to call it, and I still reproduce this behavior that seems to follow very closely the jumps and the bubble. It's an illusion. I don't know what else to tell you to convince you. The only thing that you could say, Giovanni, I don't believe you. You're cheating. You are making this up. You are bitter that as Plan B is more popular than you. No, it has nothing to do. And if you have any math skill or any coding skill, try to reproduce and do exactly what I do. I will try to make public my code, and then you can analyze it and you can see if I did any mistake. But this is exactly what it does. And if it does this because it's all bullshit, then nobody should ever talk about S2F, or at least as a lesson of how we can go wrong in modeling Bitcoin. Because it's not about sophisticated math. So to conclude, I'm going to conclude in the next couple of minutes. So basically, I'm saying something that has no hope for this model. Okay, there is no hope because I made this claim. The only thing is that if I did a error in my code, if And this is why I want to make it public so people can actually see my code, like Satoshi did with his Bitcoin code. So you can look at my code, you can see if I did any logical mistake, if there is anything wrong, you can modify, you can play with it. Basically, if you follow this procedure that Plan B described in his paper, step by step, you're going to create something that can follow anything, including falling objects, and it will have these jumps that are, in the case of a falling object, have nothing to do with what it's describing. If you do it with Bitcoin, you give illusion that these jumps have to do with something magical happening to the price of Bitcoin, but it's forced. I can come up with some other measure, like I say, these bad calls from Kramer, and do exactly the same thing, and do it with the peaks instead of doing it with the halving. I can say after 1 year of the halving, there are these events. And look at, wow, I can predict where the peaks are. I can predict when the bear market starts. And in fact, it looks almost better as a model than what he has. So there is no hope. There is no hope. It's done. And I'm sorry to be so strong and etc. It's just like, this is how you do science. If somebody comes in and finds some fatal flaw in your model where it's not doing what you're claiming that it's doing, because like here you can see, I can say it's a model. It's actually Bitcoin goes up with abundance, not with scarcity. What are you talking about? I can use this scarcity model to model things that have nothing to do with scarcity, etc. And I can show mathematically that I say I will do in another video why it does that. Why it does that? Why it has to do with what really this process of creating this quantity that jumps around like that and doubles, every 4 years is all about. Okay, and it's basically like a kind of a Taylor expansion for the people that understand. So a Taylor expansion basically can approximate anything, and by the time you do like two, three, four of these halving, it looks like it's following very nicely the process that you're describing. If a process that you're describing follows this polynomial behavior, and the illusion of synchronization with the bubble, it's there because you made it so. Like I'm making so here that there is a doubling of the bullshit when there are the peaks. That maybe is even a good theory, but it's a made up thing because I'm controlling here what is happening, and I didn't get any real data. I just made it up. And it's a model. Then we have to say that Bitcoin is driven by abundance of bullshit instead of abundance of scarcity of Bitcoin. So it's just like let's move on. Let's move on. It was a bad model. It makes me kind of upset that people stick with it because it gives like this false impression about what is going on with Bitcoin. The math is wrong, seriously wrong, and it's not a model that can produce anything useful for us. Okay, so I hope that I don't piss off anybody. We need to be, part of why we are Bitcoin is because we love truth, right? We love truth. Truth and math is the core of Bitcoin, and we need to agree, And I hope that Plan B is the first one. I invite Plan B to reproduce this abundance model that I just described exactly what they did, and then he can come to me and say, Giovanni, no, there is something that in your analysis that is wrong. Your understanding, like he's told me that I don't understand scarcity because I think I understand scarcity much better than many people, and because I really spend hours and hours and hours thinking about this issue of scarcity, but it has nothing to do with that. If I want to talk about philosophy, we can talk about philosophy another time. Don't tell me this and this. It's all about math. It's all about how this algo works, how this definition of stock to flow apply to Bitcoin. Maybe in general makes sense for other things, but when you apply to Bitcoin because of this programmatic behavior of the flow and the stock, etc., it doesn't work. It's not. You cannot use it for what you're saying that you're using, that showing that a change in flow is somehow related to the change in price, because it's garbage. I don't know what else how else I can explain it to you, because then I can come up with anything I want, like abundance. I could do all kind of stuff, right? And it is not really working. It's not really working. That jumps are artificial, completely artificial. Much more artificial with my little sinusoidal, because at least in my sinusoidal, I know exactly what I'm trying to do. I try to like kind of a bookmark almost. It doesn't. It's not pretentious. I'm not telling you, look, I have this very deep mechanism that produces this bubble. It's just sine waves, and we are bookmarking. How the shape of it. It's arbitrary. I made it in a such way that they look kind of nice in comparison with how the price goes. But it's just a bookmark of where, if they continue to be periodic like they are, where they are supposed to be, so we can predict where the next one is going to be, etc. So it's very honest, very simple, very straightforward. This is dishonest. I don't know. People say I'm forceful, but I'm dishonest. Not in the sense that Plan B. Again, please understand. This is not a personal attack to Plan B. I'm saying it's dishonest in how it works. It's maybe dishonest is not the right word. Help me out. Whatever the right word is an illusion. It's we kind of, and I see. I never heard anybody, and maybe somebody made an argument similar to this. I never heard anybody making an argument like this. The closest thing was a friend of mine, and this when I describe why this happens. I will show you what this friend of mine said, but in that case, it was like if the article. If you read his article, his name is Michael Frank. If you read his article, in the end, almost he's leaving space after his analysis for actually SOF being correct. But once you understand what is really going on, you can use his argument and reverse it and say no, because this type of algo that Plan B came up with can model anything. Can model falling objects. Can model. I can have in fact, I have a graphs where the price goes down. The price goes down and not changing anything. So instead of going up, it's going down, and the flow goes down by a factor of two. And it models perfectly that behavior of price goes down. So it can model price going up, it can model price down, it can model, I can change the flow and make it abundant instead of scarce, and model perfectly Bitcoin and all these regularities. When you have something like that can be applied to anything, because of his math, then it's garbage. And some people say, "What don't you say like?" Because people say sometimes the silliest thing. They say, "Didn't say that the power laws appear everywhere, but that is law, a real laws of nature. These are really things scale up and seems to be governed by these." I'm saying this model, because of how it's constructed, has this mathematical property of following anything that looks like this black curve. Anytime you have something that looks like that curve, even approximately, this model will approximate it. Because in the end, really, S to F is time. It's just a distortion of time. And you can argue with me how much you want with this. No, it's not really something else. It's time, and it's a distortion of time. And this is why if you have something like that, then it's time that eventually becomes exponential. So it's really, it doesn't matter what it is. It's able to fit pretty closely something that behaves in this way, and then eventually goes away from it. But initially, it gives you this illusion that it does a good job. And if you force it to have these jumps, because these jumps somehow are correlated with something that is happening in the background, then it looks like causative. Like I could make my fake model, right? This curve, I could add some fake bumps. I could put them randomly around, and then say, oh, one month before this jump, like say that I know with Bitcoin, we know, right, when they happen, but let's say they are not regular. One happens every 2 years, the other happens 3 years, etc. I could make it happen then, and then it looks like it's tracking these jumps, these bubbles very correctly. It's a made up thing, So I think, I hope, hopefully everybody understands it, what I'm describing, and you understand how fatal this argument is. But I'm sure anybody that knows how to code and knows what I'm talking about completely understands. He finally completely understand what I'm talking about. And then later I will give you a more detailed explanation mathematically why this is so. And it's not really complicated math. It's basically like it's an expansion. It's a Taylor expansion, and this is what we are seeing here. And is this model, it doesn't do what it's supposed to do. That is the bad thing. It's inconsistent with its own premises. It is the worst thing that you can say about any model, because independently of how the data looks like, if there is like some inconsistency in the model, and the model doesn't do what you claim to do, like to show that scarcity has anything to do with the price of Bitcoin, and it's gone, and you should not use it. Okay, I'm going to end here. Hopefully this is useful, and we can move on and try to understand Bitcoin from other point of view. And thank you to listen. And that this has absolutely nothing to do with personal issue between me and, because we know Plan B has been nice with me. We have even talked on DM each other, and he has been just a gentleman and a great person to talk with. And he's a clever guy. He's a very clever guy. I'm sure because this is his baby, he's attached to it. I'm not sure how he's going to react to this video, if he's going to watch it, if he's going to respond it. But I think the argument is so tight, and that gave so many counterexamples, and they show that it doesn't absolutely do what he says it does, and there is no way of recovering this model at all. And I'm waiting for his answer, or maybe somebody else telling me what is wrong with my analysis, and then maybe I will have a response. But so right now, this is where I'm going to stop, and thank you to watch.